Right, so good morning guys and Mr. Jerry. Today I would like to explain a math topic called probability. So first of all, we need to know what is the definition of probability. So the definition is an extent to which something is probable or the likelihood of something happening or being the case. So probability is divided into three segments or steps: experiment, events, and outcomes. The result of an experiment is called an outcome, or an elementary event, and a combination of these is known simply as an event.
And now I'm going to explain about mutually exclusive events and the addition law. But first we need to know how to identify mutually exclusive events. So mutually exclusive events are the events that have no common favorable outcomes. So P in bracket A and B equals to 0. In other words, that the intersection of the two sets are empty. And events that are not mutually exclusive is the events that have at least one common favorable outcome. So P in bracket A and B is not equals to 0. So in other words, that the intersection of the two sets are not empty. So to find the probability of that event A or event B occurs, we can simply add the probabilities of the two events together, but only if A and B are mutually exclusive. The addition law for mutually exclusive events, which is P in bracket A or B equals to P in bracket A plus P in bracket B. Next is Venn diagrams. Venn diagrams are useful tools for solving problems in probability because we can use them to show favorable outcomes, or the number of favorable outcomes, or the probability of a particular event. So the number of outcomes favorable to event A is denoted by A, and the complement of A is denoted by a accent. And this is the example of the Venn diagrams. This is the denotation and this is the explanation.
Hi everyone. So today I will be explaining how to answer work example 4.2. Let's see. Here. Okay, let's start. One digit is randomly selected from 1, 2, 3, 4, 5, 6, 7, 8, and 9. The three possible events are A, a multiple of 3 is selected, B, a factor of 8 is selected, and C, a prime number is selected. So let's do part A first. Show that the only pair of mutually exclusive events from A, B, and C is A and B. And we have to find the probability of A union B. Let's group them first. So A, a multiple of 3, which is 3, 6, and 9. B, a factor of 8 is selected. So 1, 2, 4, and 8. C, a prime number. So we have to find the prime numbers, which is 2, 3, 5, and 7. So the probability of A will be 3 over 9. For the B will be 4 over 9, and C 4 over 9. So now we have to show that the only pair of mutually exclusive events from A and B and C is A and B. So the outcomes favorable to pairs of events are shown in the three Venn diagram opposite. So as you can see, for A and B, they have nothing in common. A and C, they have one in common. B and C, they have also one in common. So now we know that A and B are mutually exclusive because they don't have any favorable pairs. And now we have to find the probability of A union B. We can use the addition law because A and B are mutually exclusive events. So it's 3 over 9 added with 4 over 9, which will be 7 over 9. Yep. So now let's move on to the B part. Here it is. Okay, so first we have to find the probability of A union C, and the second one we have to find the probability of B union C. So here's the way. So since set A contains of 3 of the 9 elements, we put here 3 over 9, which will be added with the set C, which have 4 over 9, and will be subtracted with the A intersect C, which is they have one of the 9 elements in common, so it's 1 over 9, which the answer will be 6 over 9 or 2 over 3. So that's the probability of A union C. And for the BII, almost the same way as the probability of A union C. So set B contains of the 4 of the 9 elements, so it will be 4 over 9. Set C contains of 4 of the 9 elements also, so it will be 4 over 9, and will be subtracted with probability of B intersect C, which will also be 1 over 9. So the answer will be 7 over 9. So we can read here in the first part of B above, we subtracted A intersect C. It's because the common elements in A intersect C have been counted in NA and in NC. We follow the same steps when working directly with probabilities. This also applies to the events that are mutually exclusive, where the number of elements is equal to 0. Yeah. Okay, so that's all from me.
So hello everyone. Today we're going to talk about some examples related to the Venn diagram. So let me present my screen. Okay, here it is. Work example 4.3. In a survey, 50% of the participants own a desktop D, which is here, and own a laptop L, 60% of it L. L is labeled Q and D is labeled P. And 50% in the next section own 0.15. 0.5, 0.6, and 0.15 is already converted to decimals from the percentage. So our objective is to find the P, Q, and then find the value of X, which will answer this question here. What percent of the participant owns neither a desktop or a laptop? So let's find P first. So P, we will calculate this one first. 0.5, which is 50%, minus by 0.15, and we get 0.35. And moving on, we calculate Q, 0.6 minus by 0.15, which will be 0.45. So both of P and Q, we already find the value. So now we want to find X. So finding X, we do 1 minus bracket 0.35, the value of P. So I'm going to say VP as an abbreviation. I'm going to say the value of P plus 0.15, which is the intersection, plus VQ. VQ is the value of Q, which is 0.45, and if we calculate it, we're gonna end up with 0.05, or we could say in an alternative way, we could say 5%. Okay, as simple as that. So that's how we find for the first example. The second example now, let's look at the second one. 40 children were each asked which fruit they like from apples, which is A. This is the apples. B is the bananas. C is the cherries. The following Venn diagram shows the number of children that like each type of fruit. Find the probability that a random selected child likes. Okay, so we need to pay attention to this one, that randomly selects child that likes apple or banana. So focus both on A and B. So we're going to use the formula this PAB. That's the formula that you should understand. So P A U and a B. Okay. If I don't write. Okay. So when you find the answer, we're going to rainbow multiplication, you can call it. So it's going to be PA plus PB minus once again with this. Okay, minus once again with this. Okay, is equal to 17 PA. So the PA, the P of the apples is 17 over 14. 17 is from here, from all the intersections of A, so which is 17 here. This is the result. So 7 plus 8, A plus 3 is 11, and then 11 plus 6 will be 17. Okay, plus PB. PB it's here. This is B. So it's all the intersection as I said. So 2 plus 2 4. 4 plus 1 5. 5 plus 3 is of course 8. So it's gonna be 8 out of 840, and then minus 4 out of 40. Okay, minus 4 out of 40, which is this intersection between A and B. So it's 3 plus 1, it's going to be 4 out of 40, and then the result, the final result will be is equal to 21 over 40. So this is the answer to this, that select a child that likes apples or bananas. Okay, so there you go. That's the examples that are those are the examples that are related to the Venn diagram, and thank you for listening.